Hey guys, so like we said this week in the Google Meet on Tuesday, I was going to go over the distribution review, and I was asking for different questions on which ones you might want to go over. So one of you did speak out and say that you want to go over example 1, so that's what I'm going to do in this video, and if you want to go over any more, feel free to post it in Modo and I can go over another one, but I can go over this one for now. So with example 1, it is talking about batteries. So talking about battery life and relative frequency. So like we've done before, we're going to plug this into our calculator. So I'm going to go over a couple of steps of how to do that in case you guys forgot. So the first thing you do is press the Stat button, click Edit, and then you're going to enter into L1 and L2. So those are your two lists. So once you do that, well, L1 is going to be your data, L2 is going to be the frequency. Then after that, once all the data is entered, you can kind of quit out of that and then go back to Stat, but this time you're going to click Calc, and if you want like a little shortcut, you click number 1, or you click on one variable stats, so that's what number 1 is going to take you to, and then it's going to pop up with a screen that says List and Frequency List. Your list, you want to make sure it says L1, frequency list says L2. So that's your main thing. So let's quickly do that, but first we have to try to calculate what these values are. So it's kind of going to be a little bit of an estimation. So if I kind of eyeball it a little bit, so this lines up, it looks like with maybe 0.03. So we'll say this one's 0.03. This next one looks like it's lined up with 0.05. And then you keep on going, 0.08. Looks like this one's about 0.17, 0.17, 0.14, 0.17, 0.05 is this little one, 0.08 again, and then 0.03, and then 0.03 again. So like I said, these might be a little different from what you guys are receiving from this question because it is kind of eyeballing it. So like for example, I said this one was 0.17, maybe you think it's 0.18. So it just kind of depends on what you are receiving for those numbers. So now it's time to type these in our calculator. So like I said, we go Stat, Edit, and then type it into list 1 and list 2. So here's our list 1 and list 2. So like I said, list 1 is going to be our data. So it's not going to be our frequencies. Our frequencies is what we just calculated. So our data is going to be right here. So we have 80. So now we kind of exit out of that, so you can go to second quit, take you back to the main screen. Then you go with Stat again, move over to Calc, and then you can click number 1 or just click Enter because you want one variable stats. So click Enter, it takes you to this screen with List, so we want L1, and then the frequency list we want L2. Click Calculate. Okay, so as you can see right here, the little X with the bar on top, remember that means mean. So our mean is going to equal 103.9. Like I said, if your values are a little off from mine, it might be a little bit different. So keep that in mind, so you might not be completely wrong. And then it looks like the standard deviation, as you can see right here, is 12.6. So now we know our mean, the standard deviation. So now let's look at the questions that come with this. So question 1 says, would you describe the distribution of battery life as approximately symmetric or as skewed? Explain. So if we're looking for something that's symmetric, we want like a bell shape, right? So we want it to go up, nice to a peak, and then come back down. And in this case, it does look like a bell shape. So we're going to say that it's approximately symmetric. You can say bell-shaped. Then we can also say it looks higher in the middle and lower on the sides. Okay, and then that would be a good enough explanation for that one. Question 2 says, is the mean of the battery life distribution closer to 95, 105, or 115 hours? Explain your answer. So we did calculate the mean. Our mean was roughly 103.9. So it looks like it's going to be closer to 105. So we can say closer to 105. And if we look here to just double check on our graph, 105 is right here. And that's approximately center of the data. So we know that that's going to be correct. So we can say that 105, so this is closer to the center of the data. And then if we look at 95 and 115, 95 is right here. That doesn't really look center of the data. There's way too much on this side. And then if we look at 115, 115 is right here. Too much on the left side. So as you can see, they're not really centered of the data. So 105 is for sure going to be the answer. We can say the other values are left and right. Okay, sure you guys can see that. If we move on to question 3, I think this was one that was giving some of you guys a little bit of trouble. So this one's going to talk about standard deviation. So it wants us to consider 5, 10, and 25 hours as our standard deviation. And if we look back at what we received, we got 12.6. So let's take a look at part A. It says consider 5 hours as an estimate of the standard deviation. Is this a reasonable description of the typical distance from the mean? So right here, standard deviation, 12.6. 5 is probably not going to be a reasonable estimate, but let's really see why. So up here we said our mean is close to 105. So let's keep 105 in mind in terms of our mean. So if we look back up at our graph, here's our mean, 105. Use a red pen. If our standard deviation is only 5 hours and our mean is at 105, that means it's going to take us from 100 to 110. And that's hours. So from 100 to 110, our values are 0.17, 0.14, and 0.17 for our relative frequency. So we have 0.17 plus 0.14 plus 0.17. That's going to equal 0.48. So you're probably wondering, what does that even mean? Why is that going to help us in this question? So 0.48% of the data is included within one standard deviation. However, we know from the front page, a normal distribution, 68% of the data is supposed to be within one standard deviation. 95% of the data is supposed to be within 2 standard deviations, and 99% of the data is between 3 standard deviations. In this case, we're only looking at 1 standard deviation, right? Because it says the estimate of the standard deviation. Consider 5 hours as the estimate of the standard deviation. So we're just looking at 1 standard deviation. So from 110 or 100 to 110, 0.48 is not really that close to 0.68 because we want 68% of the data. So what we can say is 5 hours is too close to the mean. In other words, this is what we're looking at. This grouping right here. This is what we have between 1 standard deviation. That's not 68% of the data. We have all this data over here and over here. That's definitely not 68%. So 5 hours is too close to the mean. The majority of the data, and let's going to be, let's get rid of that. That's going to be 68% is the majority, is what we want. Should be 1 standard deviation away. Like we said, 48% of the data is included within 5 hours as an estimate of the standard deviation. So if that doesn't quite make sense, hopefully it makes sense when we look at 10 hours. So if we consider 10 hours as an estimate of the standard deviation, let's see if this is a reasonable amount. So this is closer to the 12.6 that we got. So we're probably going to predict that it is going to be a reasonable amount. So like we said, our standard deviation is 105. So if we have 10 hours as our estimate for standard deviation, we're going to be going from 95, so that's right here, to 115, which is right here. So that looks like it might be closer to 68% of the data. So that's we're on a good track with that. So it's between 95 and 115 hours. Okay, and let's kind of add up like we did before with the 0.17. We just added those up. So in this case, we have 0.17 plus 0.17 plus 0.14 plus 0.17. I think .15 as well, or 0.05. 0.05 included, let's see. So we have 95, 100, 105, 110. Yes, 0.05. Okay, if we add those up, we get 0.70. Okay, 0.70 is a lot closer to the 0.68 that we're looking for within one standard deviation. So that's a good sign. So what we can say is this is closer to 0.68 because we have 0.17, which 0.68 should be within one standard deviation of the mean. So hopefully that makes a little bit more sense. So right here, as you can see, from 95 to 115, this is 68% of the data, or as we got 70%, which is really close. So this is a reasonable amount. So now let's look at C. We have 25 hours as an estimate of the standard deviation. So if our mean is 105, then this is going to be between 80 and 130 hours. And our first immediate thought should be that this is a huge interval. So we have 80 is right here, and 130. That is a huge amount of data. We're only looking for 0.68 or 68% of the data. This is getting closer to 80 or 90% of the data. So we can say that no, this includes almost all of the data. So it is well over 68%. So with these questions, if it's looking for you to find a reasonable amount for the standard deviation, you just have to make sure that you're following the intervals for what the standard deviation is giving you. You're taking that amount of data, you're looking at your graph, and you can predict right away, is this going to be, in the realm? Then you add up the numbers and double check your work. So if you have any more questions with that, definitely, I think there might have been a similar question on example 2. Looks like it. So if you have any more questions on that, I can make another short video if that didn't make too much sense to you. Definitely feel free to post a comment in Edmodo, and I can definitely try to word that a little different, but hopefully that works for you guys. And definitely, if you have any more questions, feel free to ask tomorrow during the meet on Google.